In previous class, we have discussed the proof for the properties 0 or x will be x, and for b 1 or x will be 1. So next we have to see the proof for the third and fourth, that is 0 and x will be 0, and d is 1 and x will be x. See, first I am going to be select C, 0 and x will be 0. So by using proof by perfect induction, proof by perfect induction. What is proof by perfect induction? By substituting the possible values, we have to prove it. See, if x value is 0, then LHS, I'm going to take 0 and x. I'm going to be substitute the x value as 0. 0 and 0 will be 0. So which is RHS? Which is RHS? If x value is 1, then LHS 0 and x. We are substituting the x value as 1. Then it will be 0 and 1 will be 0, which is RHS. So therefore, based on these two, we can say 0 and x will be 0. So by using the truth table also, we can able to solve it. By using truth table, 0 and x will be 0. 0, 0 and x. Sorry. 0, x, 0 and x. 0, 0, 0, 1. So when we have one variable, the possible values will be 0, 1. The possible values will be 0, 1. So 0 and 0 is 0. 0 and 1 is also 0. So from this truth table, by observing the columns of x and 0 and x, by observing the columns 0 and x, both values are same. So therefore 0 and x will be 0. The other one what we have is 1 and x is 1. So that will see D 1 and x is equals to 1. So by using proof by perfect induction, proof by perfect induction, proof by perfect induction. So if x value is 0, taking LHS 1 and x value I am substituting as 0, then it will be 1 and 0 is 0. That is, sorry, what is the question? That's a property 1 or x. Sorry, 1 and x is x. So this is x value, which is RHS. Because x value we have substituted as 0. So because of that, we'll be getting RHS. If x value is 1, then LHS is 1 and x. X value I am substituting as 1. 1 and 1, that is 1. 1 value we have substituted as, x value we have substituted as 1 here. So this is x. We got RHS. Therefore, 1 and x will be x. By using truth table, by using truth table, by using truth table, 1 x 1 and x, 1 1 0 1. So 1 and 0 is 0 and this is 1. So by observing the columns of x and 1 and x columns, both are same. See, by observing x and 1 and x, both the values are columns, both the values are same. Therefore 1 and x will be x, 1 and x will be x. So these are the properties, 4 properties we have with the zeros and ones. These are the 4 properties with zeros and ones, or properties of 0 and 1. Next property we have idempotence law. Idempotence law. So what this law is going to be state, when a variable is going to be combined by itself by using or and operations, again the output will be the same variable. See, this law states that when a variable combines with itself using or and operation, sorry, will get same variable as output. This is a statement. This is a statement. This is a statement. Now see, x is a variable. It is going to be combined by itself by using or operator, will be getting the the same variable. Will be getting the same variable. And the next one also, when a variable is going to be combined by itself by using and operator, will be getting the same variable. See, the logic gate for this, x or x will be x will be x, x or x will be x. This is OR operator. And next for this AND operator, x will be getting x, and operation. This is a statement, idempotence law statement, most important one, idempotence law statement. So when a variable is going to be combined by itself with or and operator, again we are going to be get the same variable as output, then that variable, that law will be considered as idempotence law. Idempotence law, we'll see the proof for that. Next we'll see the proof for this. See, proof. First one I am going to be take x or x will be x. By using proof by perfect induction, by using proof by perfect induction, we are going to be substitute all the possible values. Here also in this expression, we have only one variable, that is x. If x value is 0, then LHS we are going to be take as x or x. 0 or 0 will be 0. That what we have taken as x value will be getting as RHS. Will be getting as RHS. If x value is 1, then LHS is x or x. X value we are substituting as 1, and here also 1. So now 1 or 1 will be 1, which is x. So that is RHS. Therefore, we can say that x or x will be x. So this is one way of proving this theorem, and the another way is by using truth table. We can prove this. X is one variable, x is another variable. I am going to be take here x or x. So 0 1 0 1. So 0 or 0 will be 0, 1 or 1 will be 1. So we are going to be get therefore by observing the x column and x or x column, we can say that x or x will be x. So two ways we have proved by using proof by perfect induction. It means by substituting all possible values we have proved, and by using truth table also we have proved. And now we have x and x will be x. So first proof by using proof by perfect induction. Proof by perfect induction. Now we are going to be take, if x value is 0, then LHS x and x, 0 and 0 will be 0. That what we have taken here as x value, that is x RHS. Now if x value is 1, taking as LHS, x and x, 1 and 1 will be 1. That is what we have, the x value will be getting the RHS. Therefore x and x will be x. And by using truth table, we can able to prove this. X and x, 0 1 0 1, 0 and 0 is 0, 1 and 1 is 1. So by using this truth table, after observing the columns x and x, we can say that x and x will be x. So because in the column x and x both are same, because of that we can say that is a same, that is same. Next property, we have involution law. Next property, we have involution law. So what is meant by involution law? See, Involution law in a sense, when we are complement a variable, will be getting the complementation of that variable. Again, if we complement that, we are going to be get the actual variable. So this law states that complement of a variable is complemented again will get same variable. Will get the same variable. Let's suppose x bar whole complement will be x. X complement whole complement will be x. Logical symbol will see. So we are getting this is a or not operator. X if we are taking will be getting x bar. Again we are going to be complement 8 will be getting x double complement, that will be x. So when we are complementing a variable, again if we complement 8, we'll get the same variable. That is a statement of involution law. Next we'll see the proof for this. Proof. So what is the proof? So we have to prove like x bar whole bar will be x by using proof by perfect induction. Proof by perfect induction. So here, if x value will be 0, then x complement will be 1. So then x complement will be 1. X complement will be 1. X complement whole complement will be 1 complement, that will be 0, which is x. If x is 1, then x complement will be 0. X complement whole complement will be 0 complement will be 1. That is x. So now this is RHS. This is also RHS. Therefore, x complement whole complement will be x. Now by using truth table, x complement whole complement, x complement whole complement. So x value is 0 and this is 1. X value is 0, x complement will be 1. X value is 1, x complement will be 0. X complement is 1 and its complement is 0 again. X complement is 0 and its complement is 1. So this is a truth table. By observing the x column and x complement whole complement columns, both the values are same. Because of that, we can say x complement and its complement is again the x.